The U.S. Government Accountability Office, GAO, says brain-computer interfaces, or BCIs, could become one of the most transformative technologies of the coming decades. These systems create a direct communication link between the brain and external devices, allowing people to control computers, prosthetic limbs, wheelchairs, or even drones using only their thoughts. Today, BCIs are primarily being developed for medical purposes, as researchers hope they can restore movement to people with paralysis, help stroke patients regain function, allow individuals with ALS to communicate, and potentially restore certain forms of vision or hearing. Instead of relying on muscles or nerves, BCIs interpret electrical signals produced by the brain and translate them into commands for external devices. There are two main types of BCIs, with non-invasive systems using sensors placed on the scalp to read brain activity, which are safer and easier to use but generally provide lower signal quality. Invasive systems require electrodes to be implanted directly into the brain, offering much higher precision but carrying surgical risks and long-term medical considerations. Beyond healthcare, the technology has attracted military interest, as future BCIs could allow soldiers to control drones, robotic systems, or other equipment hands-free while maintaining awareness of their surroundings. The GAO also highlights significant concerns, as BCIs interact directly with brain signals, raising unprecedented questions about privacy and security. Brain data could potentially reveal sensitive information about a person's intentions, emotions, or health, and if these systems were hacked or manipulated, the consequences could be far more serious than with conventional computers. While BCIs are intended to restore lost abilities, future generations of the technology could potentially improve memory, attention, reaction time, or cognitive performance in healthy individuals. That raises ethical questions about fairness, access, military use, and what limits, if any, should be placed on enhancing human capabilities. The GAO concludes that brain-computer interfaces hold enormous promise but also present major policy challenges, as policymakers will need to address issues such as medical safety, cybersecurity, privacy, informed consent, equitable access, and ethical standards as the technology advances. If these challenges can be managed, BCIs could fundamentally change medicine, human-computer interaction, and even the future of work and national defense. The potential of brain-computer interfaces to reshape society invites endless possibilities, igniting conversations about innovation, ethics, and the future of human capabilities. As BCIs become more accessible, their integration into education, healthcare, and daily activities could transform how we learn, connect, and thrive in an increasingly technological world. The ongoing development and research into brain-computer interfaces promise revolutionary advancements in how we interact with technology, potentially leading to unprecedented enhancements in quality of life. The implications of BCIs extend beyond individual use, as they could enhance collective decision-making and responsiveness in critical situations, paving the way for smarter, more interconnected communities. As research continues to evolve, the exciting possibilities for brain-computer interfaces open doors to new experiences and capabilities that were once confined to the realm of science fiction. The dialogue surrounding BCIs is not just about technological advancement, but also about how these innovations can enrich our lives and enhance social interactions in meaningful ways. By inspiring younger generations to explore and understand brain-computer interfaces, society can cultivate a future where innovative solutions change lives and improve overall well-being. As brain-computer interfaces continue to advance, they have the potential not only to enhance individual capabilities, but also to bridge gaps between generations and foster deeper human connections. The global impact of brain-computer interfaces is unfolding as researchers and practitioners collaborate across disciplines, highlighting the importance of shared knowledge in pushing the boundaries of what these technologies can achieve. This convergence of creativity and technology could lead to groundbreaking applications that redefine how we interact with the world around us, empowering individuals to harness the full potential of their minds. The transformative power of brain-computer interfaces not only benefits those with disabilities, but also enriches educational environments, paving the way for tailored learning journeys that recognize each student's unique potential. As public interest in brain-computer interfaces grows, discussions surrounding their ethical implications become increasingly vital, ensuring that advancements are guided by responsible practices and equitable access. The journey of brain-computer interfaces is marked by significant breakthroughs that spark not only technological advancements but also deep emotional connections, demonstrating their potential to change lives fundamentally. As brain-computer interfaces become more intuitive and user-friendly, they empower individuals of all ages to seamlessly integrate technology into their daily lives, facilitating connections and enriching experiences. This collaborative spirit fuels innovation in brain-computer interfaces, driving researchers and creators to push boundaries in technology and find new solutions to enhance user experiences.